to talk about a new idea I have for blood filtering, and this could be used. And blood filtering could, if done well, and we have to also have a lot of problems with heat resistance. The heat thermal shock that I've talked about before is a huge issue, and stopping blood clotting and all these other issues. But it could lead to a wide range of new therapeutics, because if we orally inject something, it isn't as controlled the dosage you get, and you have your liver and all these other things in your body that can digest it or change it, intestinal. And that's for oral. If we breathe it in, same is not as controlled. Or if we put it in injection, it might not be as controlled as sudden. And also it might leak, it might have more toxic effects. If it's in a vat, if you have something filtering out the body in a vat that's separate from your body, it doesn't go through your liver or anything that might digest it or flush it out at different rates. You can control the rates very much, so you could adjust it and do a lot more fine-tuning than with drugs. You could have less toxic side effects, like let's say it's only toxic for the brain. Well, it's stuck in the vat, so it never reaches the brain. And you could also quickly make stuff that filters out different toxins or anything, but not only toxins, it could filter out stuff for your to lower inflammation responses, which a lot of diseases actually kill you by the inflammation they cause and not by the actual virus or something. So how do I think we could do this in the future? Well, first of all, this whole system would have to be well insulated, so there's no thermal shock that causes proteins to get damaged. And I also think there should be an ultrasonic or something to shake the whole thing, so there's no blood clotting. But then what we have is your blood will go into one of two bags. In the simplest version, this bag will filter out the blood, and this bag won't. And that way you can control the weight, so it doesn't filter out too much of something or too little. You put more into this bag when there's not enough stuff. You put more in this bag when there's too much of stuff. So you can control the weights, and then you could have also 500 different bags and different complicated plumbing, so you can filter out more than different things at different weights. Just all how much stuff into one bag or another bag. And then to detect how much in this bag, how much is in the body, you can actually just look at absorptivity rate, because how fast something is absorbed is a direct function of how much free particles here are still left to absorb it, and how much it concentrates in the blood. To make also stuff to absorb it, it's generally a lot easier to design. That's with designing antibodies, and typically designing antibodies are a lot easier than designing complicated drugs. Typically, there are definitely exceptions, but it's also a ton more easy if you don't have to put in the body. A ton more easy. So then you got that. Well, how do you detect the rate that stuff is being absorbed? One is you could have these particles floating around suspended, and the heavier they get, the less they suspend as they absorb more stuff. You can measure how well they're suspended just by shining light through, and the less suspended they are, the cloudier it will get as they are less well dispersed, and the more they'll settle to the bottom. You can see that with a light beam. I've done that experiment. It's very simple calculations and easy to do. You can suspend them with a variety of ways, such as a magnet, or you could just have it lightweight enough. Another one is you could use Brownian motion to detect how fast it's moving around. And Brownian motion is just that random moving of something due to thermal energy and mass. And you can see this on a plate where if you put hot water on a plate that's really hot and boiling, a little drop of water, it'll randomly move around, oil and stuff. And Brownian motion depends on the particle size, the temperature, and its mass. So you could detect it that way. And both of these two ideas could easily be combined. A third way is you could use a magnet or something to vibrate it and see how much it's vibrating, which is also a function of weight. The more it vibrates, the slower it vibrates, the higher its weight. And the more up and down it goes, the lower its weight. Another way you could do it is you could look at how well everything sticks together. And that, to make it more exaggerated, because you could have one molecule bind two of these suspended particles that are filtering out of your blood together, and they will get bigger. or they could bind to other things. You could have it release a dye, have a dye that changes color depending on if the thing is binded or not, which has been done and is more sensitive, but it's hard to design. One way is some dyes, if they're bind to something, the electronic properties change. And remember that a light is absorbed by it binding by electron jumping from a lower state to a higher state, and it's emitted if it goes from a higher state to a lower state. But if a dye binds to something, it can either change. It can have electrons go from the thing it's bound to the dye, or vice versa. This can change the whole dynamics. It can also change the whole dynamics, so the dye might move differently in an electromagnetic field, which can change its thermal properties, changing its emission. Because, for example, water absorbs microwaves by literally spinning around as like a teddy bear. But now if it's heavier, that can't spin around faster and will actually absorb different light if water is bound to something. You could also, there's other ways that dyes could do it. Dyes could even change the shape of a molecule by binding it to different regions. You could just do simple spectroscopy, where you just shine a light and see what light is absorbed, what light is reflected, and so on and so on. And all these methods you can combine. You could have biological sensors, where you have complicated enzymes and stuff to sense stuff, and that's more adjustable, but much, much harder to design. Something I forgot to put here is you could have things that change shape when they bind to different things, which could change the properties, such as the antibody that binds to it stretches out a certain molecule or something by bringing together. Like if you have a two pieces of if you have like a sandwich, you can imagine that you have this is one way you could do it is you have a sandwich, one color. This would be black, but you could have something where something binds to it over here. This is now bound, and because it's bound, this then collapses and becomes more flat, or it binds to the top here and closes off from being at an angle, or some other way it binds to something and stretches out, or maybe this was weakly attached and now it's free and open. You can combine all these ideas in a multitude of ways. Just pointing out. Now, when you want to recharge the system, either you would have to put a new system, or which is not the best idea, because every time you switch in and out stuff, you have to have more personnel on file keeping track, or so that's more shock because you have to put in new needles or more other things, which just increases the rate that anything goes wrong a lot more, which over many, many patients is actually a very big deal, and especially during crisis when you're running out of supplies. So, and also in between, you're not getting the filtering. So how do I propose to recharge the system without this? Or one is to put I think an electric current could free up from antigens, because antigens they don't have the strongest bonds to the molecules attached to. They have what they have is, what they have, so strong bonds are covalent, and that's when atoms are literally attached to each other like this. They have usually weaker bonds based on one of them having a slight charge, positive, negative, another one having the opposite charge. There, a little electric current can split it up easily without damaging the antigen. Then once you split it up, if you pass in liquid that's clean, it can just flush it out, and you can flush it down a separate pipe to the outside world or to the urinary tract, and then they just pee it out. Another way they could do it is you could have some way to produce more antigens, and you just put those more antigens into the system to filter out. We can produce antigens very, very cheaply once we know how to do it. Comparatively very cheaply. It depends a lot on one. Some of them are super, super cheap. Some of them are a bit more expensive. By genetically engineering bacteria and more to produce it, and it's putting the genes in there. So all this could do it. And then you can take the old ones and you can have stuff that degrades those old ones, which is a lot more hard, but still possible. I hope you found this interesting. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I'm certain I can do it. Thank you very much. Goodbye.